back to a whole new episode of Science Learning. Sit back and relax as we continue our journey on potential energy and conservative force. I am your teacher Jason, your science teacher for today. Today's video, you'll be able to first, second, third. Hand washing is a very important measure to prevent the spread of infectious diseases like COVID-19. Are you observing frequent and proper hand washing? If yes, keep it up. If you think you are not doing, you'll find in this lesson why you need to take it seriously. Are you ready now to learn more? Before we formally dive into learning more about potential energy and conservative force, let us play a game for us to be able to review the important concepts related to our lesson. Rearrange the following scrambled letters into the correct words. I am giving you 1 minute to do the puzzle. Your time starts now. How did you find the game? Were you able to rearrange the words which are related to our topic? Are you familiar with these words in the puzzle? Good job! It seems that you are now familiar with the terms from the previous lesson about work. This time, let us perform again another activity. In the previous module, we found out that the work done by the resultant force acting on an object equals the change in the object's kinetic energy. Indeed, we carefully defined kinetic energy in such a way that any change in it would just equal the work done on the object by the resultant force. So this equality is not too surprising. Today, let's perform an activity again. Look for a ball, let it roll on the floor at a certain distance. Then, answer the following guide questions. You did a great job! Somehow, an ability to do work because of motion is stored with a moving object. And we associate with this ability the kinetic energy with a formula. Let us learn it deeper through performing the next activity. Does every force an associated potential energy? Let us try to find out. Let's perform the activity, Perform Me. You will need stone, rubber band, and recording notebook. With the stone in your hand, throw it vertically upward. Observe the speed and the position of the stone. Good job! Next, get the rubber band and stretch it to its elastic limit. After performing the activity, let's answer the following guide questions. Congratulations! Our activity, we can say that work was done when you stretch a rubber band. Energy is transferred from you to the rubber band. Because of its stretched position, it possesses energy. This energy is elastic potential energy. If a stone is placed in between the stretched rubber, the slingshot can do work by releasing the rubber band from your hold. one of the most familiar forms of potential energy is gravitational potential energy. Consider again an object of mass lifted to a certain height. Work done on the object gives this object gravitational potential energy. The change in the object's gravitational potential energy is the work done in raising it to that height. Since the work done on the object to raise it at that height is given by the equation, then the change in the object's gravitational potential energy is where h equals the height above the reference level. If the object is raised from the ground, the reference level is the ground. If the object, however, is raised from the table is the reference level. Using the equation we have derived, can you give the unit of gravitational potential energy? Yes, you are right. The unit of gravitational energy is the same as the unit of work, joule. Total work done on a body is related not only to the body's displacement but also to the changes in its speed. Work done is transformed into energy due to motion, or kinetic energy. To derive an expression for kinetic energy, let us analyze what happens to a body when a constant force is exerted on it along the horizontal. Due to this force, the body moves a distance. We say work is done on the body, which is, using Newton's second law, we can replace the force by the product of mass and acceleration, giving us, if the body was initially moving in the direction of force with initial speed, then after moving through a distance, it will have a final speed. Using the equation for motion you studied in the previous modules, this speed may be expressed as, rearranging the last expression, we have Did you also observe that in a free-falling body, the potential energy decreases and the kinetic energy increases? Notice that as the object freely falls, the change in potential energy is equal to the change in kinetic energy. At all positions, the change in kinetic energy is equal to the change in potential energy. We may conclude that mechanical energy is conserved. The lost potential energy becomes kinetic energy. What you have observed is a good example of conservation of energy. As an object falls, will the change in kinetic energy be always the same as the change in potential energy? What do you think will happen if air friction acts on an object as it falls. If air friction acts on the object, potential energy still decreases, but the decrease in potential energy is no longer equal to the change in kinetic energy. Actually, it will be greater than the change in kinetic energy. Potential energy lost is not totally converted to kinetic energy. Some of the energy is converted into thermal energy of the molecules of the air the object encounters. If you could measure the temperature of the air around the object, there would be a little increase in the temperature of the air. The law of conservation of energy tells us that although energy changes to other forms in a given system, the total amount of energy cannot change. For example, when an object freely falls, the total energy gained when it is raised from the ground to a certain height remains the same. It is only transformed from gravitational potential energy to kinetic energy. When it rests on the ground, the kinetic energy is transformed to thermal energy of the ground and the part of the object that touches the ground. Are you ready to do the practice exercises? If not, go over the examples and study the solutions. Once you are ready, go on with the practice exercises. Solve the following sample problems. Write your answer on the learning activity. Alright! Now, it is clear to you that the gravitational potential energy of a system or object is to the configuration of the system and the elastic potential energy of a system or object to the configuration of the system. With that, you must be up for the next challenge. A concept map is a graphic organizer that illustrates the connection between terms, ideas, concepts, and processes. Fill the concept map of mechanical energy. Write your answer on a separate sheet of paper using this format. You have 1 minute to complete the figure, but you can pause the video in case you need more time to complete it. Are you done with your concept map? Here's the completed figure. Did you do the same? If so, excellent job! We're almost done with our first lesson. As an extended activity, your next task is to solve a word problem. Here is another activity in which you will be able to gauge how much do you understand our lesson. Let us see if you can follow the solutions given in the sample problems. Below are the simple problems for you to solve. This time, I will be flashing questions with options that you can choose from. You have 5 seconds to answer each question. Write the letter of your answer in your notebook. Good luck! watching this video. I hope you learned a lot from our lesson, especially in our advocacy to keep everyone safe. This has been your teacher Jason. I hope to see you next time in our next lesson. Stay safe always. God bless.